Alright, so we're at your Algebra Unit 2, Unit 2 Study Guide, Numbers, Sentences, and Problems. Alright, so we're going to start off with some order of operation problems. So we're going to remember our order of operations, PEMDAS, or please excuse my dear Aunt Sally, as someone told me today that's what it stands for. All right, so parentheses. So that is if you have anything going in parentheses, as in not these. If you had a set of parentheses in a problem and it said 5 plus 7 divided by 3, you would add these before you divided because they're in parentheses. Usually you do addition after division, but as long as it's in parentheses, you do it. This is just setting off multiplication, okay? There's no sign between them. So that's not what it's referring to when it refers to parentheses. I will evaluate absolute value first as part of my parentheses and get rid of all those absolute values first, all right? Next, you do any exponents, which they're not testing us on at all in these problems. Then the multiplication and division actually go together. They go together and you start at one side and you do any multiplication and division as you come to it. The same thing with the addition and subtraction. Next, after that, you start at one side and then do any addition and subtraction as you come to it, all right? So we'll start with this problem right here. The first thing we're going to do is evaluate this absolute value. Absolute value lines mean everything in there is positive, all right? It's just talking about the distance from 0. So the distance of -5 and 5 are the same on the number line from 0. So in the next line, we can just erase these, and instead of being -5, it's just going to be a +5. Done. All right, so parentheses are done. Exponents, there's none. So we're going to start at this side and then do any multiplication and division. We have multiplication right here, a -4 times a -2, which gives us a +8. So now we have 7 plus 8 plus 5. Now you can just add those three numbers and you're done with that problem. All right, next problem. Again, we don't have any sets of parentheses with operations inside of it, but we do have some absolute value. So this is a -7. We're going to get rid of these absolute value signs. That's actually +7. And the same thing here. It's just 5. It doesn't change to -5. It just stays 5. Again, any multiplication and division. Right here we have multiplication. 6 times -4. Remember, a negative times a positive gives you a -24 minus 7 plus 5. So again, addition and subtraction, you're just going to say -24 minus 7 plus 5 in order. All right, and the last one, let's evaluate our absolute values first. So instead of being a -10, this is just going to be 10. I'll just rewrite it. How about that? 10. All right. So we'll start at this end. We first off come to a division. So we're going to do this division first. 12 divided by 3 is 4 times -5 plus 10. Next, you're going to do your multiplication. 4 times -5 is -20 plus 10. So just add -20 plus 10 and you'll have your answer. All right, problems number 4 through 6, I'm sorry. Excuse me as I sneeze. All right, problem number 4, you're going to evaluate, you're going to substitute into the equation. They say a equals 3 and b equals -7. So evaluate a squared plus b squared. So we're just going to put 3 in here. We do put them in parentheses. Whenever you put anything into an expression, you always put it in parentheses. For 1, if you just put -7 squared, the only thing squared is the 7 and the negative would stay. But we want the whole thing so it becomes +49 instead of -49, all right? So it would make a difference in this problem. So 3 squared is 9, so it's not 3 times 2, it's 3 times 3. This tells you how many times to multiply this number by itself. 3 times 3 is 9, -7 times -7, so 7 times 7 is 49. 2 negatives make a positive. And just add those two numbers and you'll have your answer. Same thing for problem number 5. You're just going to substitute in. This time it's 2a minus 3b. So we got a is 6, 2 times 6 minus 3 times negative 4. All right, so we're going to do our multiplication. 2 times 6 is 12. And then watch this because it's a negative 3 here and a negative 4. So negative 3 times a negative 4 actually gives you a positive 12. All right, so 12 plus 12 would be your final answer. And again, on number 6, they want you to substitute into this equation. They say x equals negative 4. So we're going to put everywhere x is, we're going to put negative 4. Negative 4 squared minus 7 times negative 4 plus 10. All right, so negative 4 squared, negative 4 times negative 4, 2 negatives make a positive 16. And then again, negative 7 times negative 4 gives you a positive 28 plus 10. Add those 3 numbers and you will have your answer. All right, starting at number 7, we're going to solve sentences. Okay, so the difference between what we just did was expressions. When you add an equal sign, it becomes an algebraic sentence. All right, it's just some good knowledge to have. I'm going to move this up a little so we have a little more space to work here. 3x minus 3 equals 12, right? All right, so we're going to solve for x, which means we need to isolate x on it by itself on one side of the equal sign and move everything away. So the way we do that is by performing the opposite function. So the opposite of here, first you want to check for any like terms on a side. There's no like terms. 3x and 3 cannot be combined because this is an x and that's a constant. This one has a variable, that's a constant, all right? They can't be combined. So then I would move any addition and subtraction first and then deal with my multiplication and division, all right? So 3 is subtracted, so the opposite function is adding. So we know that technically what we're doing is adding it on this side and on this side. We know eliminate, so we don't always show that step. Sister Tiffany doesn't always show that step when she does it. But that is essentially what we're doing. So what we have left here is 3x equals 12 plus 3 is 15. All right, and then 3 is multiplied to x. Whenever there's closeness with no sign between them, it's multiplication, all right? So 3 times x equals 15. All right, so the opposite of multiplication is division. So you divide this side by 3 and that cancels here. What you're left with is x equals 15 divided by 3, which is 5. All right, then moving on to number 8. Now see, they've added a variable on both sides of the equal sign. So we want to move all our variables to one side or the other. It really doesn't matter which side you add it to. I always choose the side with the bigger number. So we have 8x and a 6x. So we know we want to move it to the side with 8x. So over here we have 8x, and we want to move this 6 over here. So there is no negative sign in front of 6, which means it is positive. So to get rid of it, we would have to subtract. So we're going to subtract 6x right here. Over here, we already have this 11. We didn't move it, but we want to move this 4 because it's over here with the variables. It's subtracted, so the opposite of subtraction is addition. All right, 8 minus 6 is 2x. 11 plus 4 is 15. All right, and then to divide, you're going to divide by the 2, right? So you end up with 15 over 2, which is not divisible. So they will say, if they want it like this, leave it in improper fraction form. Or they'll say, show as a mixed number. So a mixed number is a whole number with a fraction. So this one, 2 goes into 15 7 times. 7 times 2 is 14, so that's with 1 left over 2. 7 and 1/2. All right, number 9. So now they've added in some distributive property. All right, so distributive property says if there's a number multiplied to 2 terms inside of a parenthesis, you have to multiply by both terms, all right? So you have to multiply the 8 by the x, and then the 8 by the negative 2. So pay attention to those signs in the middle. So 8 times x is 8x. 8 times negative 2 makes it a negative 16, all right? Over here, we're going to do the same thing. 4 times x is 4x. 4 times 3 is 12, all right? And then the same thing is here. Move all your variables to one side of the equation. The 8 is bigger than the 4, so I'm going to leave the 8 right here. I'm going to bring this 4 over. It's positive. Over here, it's going to be negative. Over here, I already have a 12, and then I have this negative 16 on this side, so over here, it's going to add. All right, so combine your like terms. 8 minus 4 is 4. 12 plus 16 is going to be 28, and then do your division. All right, so on problems number 11 and 12, they're going to make you do the same kind of problems you just did, but with inequalities, okay? So that's a greater than or less than, a greater than or equal to, a less than or equal to sign, and inequality means it's not quite equal, all right? So the same thing, this acts just as your equal sign. The 3 is added, you got to eliminate it on this side and that side, so you end up with 2x equals, not equals, is less than 4. And then divide. The only thing that would happen was if this number was negative right here, and you move it over there to divide, your sign is going to flip. But if you never come to that, it doesn't really matter, all right? In this one, all right, so we have 4x plus 5 is less than 6x minus 1. So again, I usually move to the bigger side. So I'm going to move 6x. I'm going to leave 6x here, and I'm going to move this 4x. It's positive, so over here it's going to minus. All right, over here I already have a 5, and I have a minus 1. So on this side it's going to add 1. All right, so 5 plus 1 is 6, is less than. 6 minus 4 is 2x. And then the 2, again, divide. So 6 divided by 2 is less than x. 3 is less than x. So when you write this, you just flip the whole thing over to write it. So x is actually greater than 3. So if you're going to write the x first, you would say x is greater than 3. All right? You can read them either way. 3 is less than x. X is greater than 3. Okay, but just make sure your sign says the right thing at all times. All right, on problem number 12, we're going to solve the sentence. It says, the absolute value of 2x plus 3 equals 10. So how to evaluate these absolute values is that the absolute value on the other side, we move it over to the other side and it becomes a plus or minus. Is essentially what it does. So it says, we're going to solve two equations. You got to solve for 2x plus 3. You leave the exact same signs in here, equals 10. And 2x plus 3 equals negative 10. All right? So you do the exact same functions on both sides. You would go 2x equals 10 minus 3. 2x equals 7, and so x would equal 7 over 2. And on this side, 2x equals negative 10 minus 3. 2x equals negative 13, which would leave x equaling negative 13 over 2. All right? So then next on problem 13, they're going to evaluate an absolute value with an inequality sign. So when you move your absolute value, and we got your plus or minus, for positive, it stays the way it is. So it would say x is greater than 4, but when you show your negative, this sign will flip. So x is less than negative 4. All right? So the same thing for problem 14. You would change your sign. X is less than 10. And then when you show your negative, it's greater than negative 10. All right? And then they're going to give us I think I forgot my line right here. An absolute value sentence, expression is less than. So the absolute value of 4x minus 4 is less than 16. So you do the same thing you did on these other ones. Let me erase a little bit of this first. A little bit messy. So you would solve for 4x minus 4 is less than 16. And 4x minus 4 is greater than negative 16. So your sign flips when you show your negative. All right, so we'll solve for this. We'd go 4x is less than 16. We're going to add this 4 over here, plus 4. 4x is less than 20. So x is less than 5. 20 divided by 4 is 5. Same thing on this one. 4x is greater than negative 16 plus 4. X is greater than, so 4x is greater than negative 12. X is greater than negative 12 divided by 4, which will give you a negative 3. So when you write this, you can put x in the middle, and x is less than 5, and x is greater than negative 3. All right, so you can put x in the middle, and you read it this way. X is less than 5, x is greater than negative 3. All right, so problem number 16. They want you to draw the graph that best represents the solution set. So we just talked about this a minute ago. When you have an absolute value with an inequality sign, you keep your sign for the positive. X is greater than 7, and x is, and the sign flips, less than negative 7. So on your number line, here's 0 in the middle, and then here's 7, and here's negative 7. So these are greater than and less than signs, so they're open circles. If it was a greater than or equal to or less than and equal to sign, then it would be a closed circle. So this means open circles, and then x is greater than 7. So greater than means shade to the right. So you'd have shading going this way with an arrow. And x is less than negative 7. So less than means shade to the left with an arrow going that way. All right? Problem number 17, they just want you to solve for x. So solve the following inequality. All right? So again, the 6 is subtracted, so on this side it's going to add. 4x is less than 16, and then x is going to be less than 16 divided by 4. All right, and number 18, that's what it is. Number 18, they want you to solve the inequality. And it says graph the graph. So draw the graph that best represents the solution set. So we're going to solve. There's no absolute value, so we're just solving, right? So 4x is going to equal less than 10 plus 2. So 4x is less than 12. And then so 4 is less than 12 divided by 4. Let me say x is less than 12 divided by 4. X is less than 3. So draw a graph. Here's 0. Here's 3. So less than, that means an open circle. And then less than means you shade to the left. So you're going to highlight your graph going this way. Let's use my really crooked line there. All right? Open circle shaded to the left. All right, then we're going to do some word problems to end this off. Number 19, 2 planes leave an airport at noon. If the eastbound plane flies at 460 miles per hour and the westbound plane flies at 400 miles per hour, what time will they be 1,800 miles apart? Round your answer to the nearest minute. All right, so 2 planes leave the airport at noon. So they leave at the same time. So we have rate times time equals distance. You have eastbound and westbound. The eastbound plane is flying at 460 miles per hour. And the westbound plane is flying 400 miles per hour. And all they say about their time is that they left at the same time. They left at noon. So that means their times are equal. They both traveled X amount of hours. That's what they want to know. All right, so multiply this. Rate times time equals distance. So this would be 460x and 400x. Okay, so that's how we represent their distance. We know that together their distances need to be 1,800 miles apart. So you take the distance of the eastbound plane plus the distance of the westbound plane, and together they should equal 1,800. All right, so 400 plus 460 is going to be 860. X equals 1,800. I did not bring a calculator, but you need to go 1,800 divided by 860. and that's going to give you X. All right, probably going to give you a decimal. It's going to say 2, probably 2, because 8 and 8 would be 1600, and then 60 and 60, so it's probably going to be 2 point something. So when you get your 2 point, say it's 2.9, all right? This means 2 hours and then 0.9 of an hour. I'm not saying it's 9, but do your division and find out what that decimal is. What you need to do is take this 0.9 and times it by 60 to find out how many minutes 0.9 of an hour is. All right? So it's 2 full hours and then 0.9. So you're going to 0.9 point whatever the number is when you divide those two and times it by 60, and that'll tell you how many full minutes. So they went, say 0.9 of an hour is 6 minutes, then it's going to go 2 hours and 6 minutes, right? 6 minutes. And they left at noon, that means they got there at 2:06. It's easy because they left at noon. If they had left at 11, 2 hours and 6 minutes would only have been 1:06 in the afternoon. All right, problem number 20. Janet has 3 times as many dimes as nickels and twice as many quarters as nickels, okay? So she has dimes, nickels, and quarters, all right? So we're going to assign our variables. We know that she has twice as many dimes as nickels and twice as many quarters as nickels. So the one we know the least amount about is the nickels. So we're going to call that X, all right? Dimes, she has twice as many, so we're going to call that 2X. And quarters, 3 times as many, 3X, all right? All right, then for money problems, you have to multiply by your cent worth, all right? So when we put these in the equations, together she should have $4.25 in all. So we're going to add our nickels, plus our dimes, plus our quarters, right? To equal 425. What did I say? 425. 4.25. All right? All right, so a nickel is worth 0.05 cents. A dime is worth 0.10 cents. And a quarter is worth 0.25. All right? So what I do is multiply, before I ever start, multiply the whole thing by 100. That moves the decimal on all of these, but it doesn't touch anything inside the parentheses. So now we just have 5x plus 10 times 2x plus 25 times 3x equals 425. All right, so 5x, this is going to be plus 20x plus 75x equals 425. All right, so just add all your x's. 25 plus 75, it's going to be 100. 20 plus 5 plus 75. Yep. 100x equals 425. So add those, divide, and find out how many nickels, dimes, and quarters she has. All right, correction on that last problem. I got a little mixed up in my brain. She has twice as many, Jen has 3 times as many dimes as nickels. So the dimes should be 3x. This is my bad. 3x on the dimes and twice as many quarters. So that's going to change. I was thinking the answer was looking a little funny here. So this should be 3. 3, and this should be 2. All right, so we'll try that again. That's my bad. So we're going to have a 5x plus 30x plus 50x equals 425. All right, so this is going to give us 30 and 50 is 85x equals 425. All right, that's looking a little bit better. So go 425 divided by 85. That'll give you your amount of nickels. Times it by 2 to get your amount of quarters. Times it by 3 to get your amount of time. All right, this next problem is a lot like the one before. It's mixing money. They say on a trip, the fare was 50 cents for each adult and 25 cents for each child. If 30 passengers paid $10, how many adults and how many children went? So this is actually a mixture problem. So first off, we're going to put our money. So we mix 50-cent fare plus 25 cent fare. And we ended up at the end with $10. All right? What they told us is our end amount. They told us at the end we had 30 passengers. So when they tell you your end amount, you call one of these fares X and the other one 30 or the end result minus X. And it does not matter. You can call this one 30 minus X and this one X, or this one this one X and that one 30 minus X. It does not matter, okay? Either one. So again, like money, we multiply the whole thing by 100, which is going to get rid of these decimals for us. All right? So now we have just 50x plus 25 times 30 minus x equals 30 times 1,000 over here now. All right? So do your distributive property here. You have 50x, 25 times 30. So 25 times 4 is 100, and 4 goes into 37 times. 750. 750, and then 25 times, and check out this negative x right here. This is going to make it go minus 25x, all right? Because it's a positive 25 times a negative x equals 30 times, no, that's incorrect. On this one, you don't multiply the end result by, you only use your end result for your variables here. You don't multiply this, would just be 1,000 right here, okay? All right, then combine your like terms. 50 minus 25 is 25x. 1,000, and we're going to minus the 750 over here on this side because it's plus, minus 750. 1,000 minus 750 is going to equal 250. 250, and then we'll divide that 250 by the 25 that's multiplied to the x. 250 divided by 25 gives us 10. X equals 10. So which one was x? The 50-cent fare, which was the adults. So there were 10 adults, and then 30 minus 10, 20 children. All right, I was off my game in those last two, excuse me. So those word problems caught me for just 1 second. But I think we got them right. I know we got them right, so don't worry about that. Just, if you have a question, feel free to send me a message and ask it, okay? Do your very best. Make sure you know how to solve for x. Make sure you know your opposite functions. All that simple stuff and the other stuff, the word problems become easier to execute when you know how to do the simple stuff. So study. You guys are great. You'll do fine on this. You're all going to do fantastic on this test.